Hello, I will walk through Python code for unsupervised machine learning using KMeans. First, we'll start by importing all the libraries and the dataset required for this project. We'll be working on sklearn library for this KMeans. So let me load the dataset. We'll load the dataset using read underscore CSV. We'll be working on with iris dataset for clustering. So as you can see, this is the head of the data. Uh, now we have to now for machine learning we have to separate the input data and what is our mm, output result. So input data will be the sepal length, sepal width, etc. Species will be the output. So we will drop the species column. We'll use data.drop species access is equals to 1 to drop the species column and separate from the rest of the data set, and we'll put this into the x variable. We wouldn't be needing y. We will need y variable to calculate the accuracy, but we wouldn't be needing this for training our model. Let me run that. Yeah, as you can see, for calculating accuracy in the later part of the video, we have to encode the y variable. So before encoding, as you can see, there's iris setosa, iris virginica. Iris setosa has been encoded as 0. Virginica has been encoded as 2. Yeah. Now we will train the model. Here, the variable times is nothing but the number of plot points. That is the number of clusters that we will be having. Like for example, when we initialize k-means variable, we will first initialize number of clusters as 1. Then it'll undergo for loop, and the clusters will, I will increase by 1. That means clusters will be equal to 2. Like that, 3, 4, 5, and so on till 20. So we fit all these machine k-means model and append that into a list called inertia. This may take some time. Yes. Now, as you can see, the model has been trained and the inertia has been appended. Now we'll use this inertia list and plot this list to find the optimal clusters. Here, a star range is nothing but the number of this code makes a list ranging from 1 to 20. This will be the x-axis, that is the number of clusters, and inertia will be the y-axis, that is the value of inertia. What do you mean by inertia? That will be explained in just a moment. So yeah, inertia, as you can see, the plot looks something like this, uh, inverted curve, and we have to find the optimal number of inertias required. We need to choose optimal number of inertias. Now, how do you do that? The inertia value should be the least, as well as the number of clusters value should be least. Inertia value, if lesser the inertia value, more accurate the data is. Higher the number of clusters, more computational complexity. So we need to find an optimal path that will look like 3. The number of if number of clusters are 3, it will be a little bit optimal. Now let's predict for number of clusters equals to 3. Now we'll yeah. This code trains the k-means model and sets the cluster as 3. Now let's visualize how the clusters look like. So this code makes a scatter plot of all the sepal values, the iris values, and color codes it according to which cluster it belongs to. So as you can see 3 colors, 3 clusters. That is purple, orange, and green. And these red dots here are the centers of those clusters. So yeah, now what inertia means is that the distance between this center of this cluster with all the like how was the average distance between these centers? It should be the least. The lesser the value, the better this cluster, this center fits this cluster. Similarly for this center and this center. So we have three centers here. Now let's calculate the confusion matrix. That is what was the expected value and what we got in return. So we get 50, 50, 50 as a cluster. Let us print what the k-means labels look like. In other words, what did the k-means predict for us? As you can see, it has predicted 0, 0, 0, 1, 1, 1, 2, 2, 2 as labeled in this cell 0, 0, 1, 1, and 2, 2, 2. That is, it has correctly predicted which cluster Iris setosa, Iris virginica belongs to. And there's, yeah. So this is how the k-means look like. Thank you.